Okay. Hi everyone. So first let me confirm audio and video here. Is audio and video clear? Yes or no? Is audio and video clear here? Okay. Is audio and video clear? Is audio and video clear here? Is it clear? Yes or no? Good evening here. Good evening. Okay. So in the previous session here, we have started cylindrical coordinate system. Yes or no? In the previous session we have started cylindrical coordinate system. So there we have seen how to construct a cylinder. Yes or no? Okay. So I have explained two ways in order to construct a cylinder. Yes or no? So in the first case, what we have done here, we have considered a z-axis. Yes or no? And we have considered a point which is at a normal distance rho from this z-axis. Okay. So then I have asked that what is the locus of all the points surrounding the z-axis which are at the same normal distance rho. Okay, what is the locus of all the points surrounding the z-axis which are at the same normal distance rho? Okay, so what is the locus we got here? The locus is nothing but the curved surface of the cylinder. Yes or no? The curved surface of the cylinder. That is, if we try to join all the points surrounding the z-axis which are at the same normal distance rho, then you are going to get the curved surface of the cylinder. Yes or no? So this is one way I have explained, and another simple way also I have explained here. What is that? If you place the circular rings of same radius one upon the other up to some height h here, it is also going to form what? It is also going to form the curved surface of the cylinder. So these are the two ways to construct a cylinder. Yes or no? Next, I have explained the cylindrical coordinates. What are the cylindrical coordinates here? Rho, phi and z. Yes or no? Okay, so in the previous lecture I have clearly explained what do you mean by rho, what do you mean by phi and what do you mean by z. Yes or no? So in order to represent any point on the surface of the cylinder, okay, in order to represent any point on the surface of the cylinder, we need three coordinates. Those three coordinates are nothing but rho, phi and z. So I have explained in detail what do you mean by rho and what do you mean by phi and what do you mean by z. Yes or no? Rho is the normal distance from the axis of the cylinder to any point on the surface of the cylinder, and the differential length along rho is nothing but d rho a rho cap. Yes or no? Where phi is nothing but what here? Phi is the angle between x-axis and rho, and it is measured with respect to x-axis in anti-clockwise direction. So as phi varies, you are going to move along the circumference of the circle. Yes or no? And the differential length or the differential arc length along phi is nothing but rho d phi a phi cap. Yes or no? Next, the differential length along z is nothing but dz az cap. Now here rho will give you the feel for the size of cylinder. As rho varies, the size of the cylinder is going to vary. Yes or no? Phi will give you the feel for the movement along what? The movement along the circumference of the circle. And z, as z varies, what will happen here? The height of the cylinder is going to vary. Understood? So all these three things we have seen. Understood? Next we have seen how to represent the cylindrical coordinates in terms of what? In terms of rectangular coordinates, and rectangular coordinates in terms of cylindrical coordinates. Okay, so what we got here? Cylindrical coordinates in terms of rectangular coordinates. What we got? So we got rho is equal to what? Rho is equal to square root of x square plus y square. Phi is nothing but tan inverse of what? Tan inverse of y by x. Z is same as z. So this is cylindrical to what? Cylindrical to rectangle. Understood? Similarly, we have represented the rectangular coordinates in terms of what? In terms of cylindrical coordinates. What we got here? X is equal to what? X is equal to, so we got x is equal to rho cos phi, y is equal to what? Y is equal to rho sin phi, z is equal to what? Z is equal to same as z. Okay. So this is what we got here, yes or no? So this is the representation of cylindrical coordinates in terms of rectangular coordinates, and this is the representation of rectangular coordinates in terms of what? In terms of cylindrical coordinates. Understood? Okay. So see here, if you want to understand this subject clearly, you have to follow all the lectures here. So up till now I have given lecture 1, lecture 2, lecture 3, and this is lecture 4. Okay. So if you want to understand this lecture, you have to go through the previous lectures, lecture 1, 2, 3 and 4. Understood? Okay. So daily my lecture is going to start at this time, that is 4 p.m. Okay, and it will continue for 1 hour, minimum 1 hour, and it may take 1 hour 15 minutes or 1.5 hour like that. Okay. Okay, yeah. Okay. Okay. So this is what we have seen in the previous session here, Okay. Okay. Next. So in today's session we will see about aero cap and A5 cap. We will study about this aero cap and A5 cap. Okay. See here. Now if I consider rectangular coordinate system here, so this is x axis, this is y axis, and this is z axis. So if I consider rectangular coordinate system. Okay. So now if I represent any point here, some point here, understood, in rectangular coordinate system in some 3-dimensional space, somewhere I have represented one point. Understood? Okay. So from this point, the direction of Ax cap here, what is the direction of Ax cap? The direction of Ax cap will be always what? Will be always parallel to what? Parallel to x. Yes or no? Parallel to x axis. So Ax cap will always point in which direction here? Parallel to x axis direction. Similarly, the direction of Ay cap, will always point parallel to what? Parallel to y axis. Yes or no? Similarly, the direction of Az cap, will always point in which direction here? In which direction? Parallel to z axis direction. Similarly, you can take any point here, in 3-dimensional space. So at each and every point, the direction of Ax cap will be always parallel to x axis, the direction of Ay cap will be always parallel to y axis, and the direction of Az cap will be always parallel to z axis. Understood? So whatever the point you can take in rectangular coordinate system, at each and every point the direction of Ax cap is always parallel to x axis, the direction of Ay cap is always parallel to y axis, and the direction of Az cap is always parallel to z axis. That means what here? The direction of these unit vectors Ax cap, Ay cap and Az cap are fixed or not? Yes or no? So whatever the point you can take here, always Ax cap is going to point in this direction, Ay cap in this direction, Az cap in this direction. So at each and every point in 3-dimensional space, in case of rectangular coordinates, the directions of Ax cap, Ay cap and Az cap are fixed. Yes or no? So is this point clear here? Tell me here, is this point clear? Yes. So is this point clear? Okay. Okay. So now coming to cylindrical coordinate system here. So I am drawing the cylinder here. Okay, so I am drawing a cylinder. So now if I join all the centers of these circular rings, I will get one axis. So this axis we are calling it as Z axis. Now this is X axis and this is Y axis. This is Y axis. Now see here. Now if I consider a point here, if I consider a point somewhere here, or you can consider here, okay, if I consider some point here, understood, okay, so the normal distance from this axis to this point is nothing but rho. Okay, so the direction of rho at this location is pointing in this direction. Yes or no? This is the direction of aero cap. Now if I consider some point here, the normal distance from this axis to this point is nothing but rho. Now at this point, the direction of rho is pointing in this direction. Understood? Similarly, if I consider some point here, the normal distance from this axis to this point is nothing but rho. The direction of aero cap is going to point in this direction. Now here at this point, the rho is going to point in this direction. So aero cap is pointing in this direction. Now if I consider this point here, aero cap is going to point in this direction. If I consider some point here, so this is rho, so aero cap is going to point in this direction. Understood? Now if you observe in cylindrical coordinate system, okay, see at this location, aero cap is pointing in this direction, and at this point aero cap is pointing in this direction. At this location it is pointing in this direction, at this location it is pointing in this direction, at this location it is pointing in this direction. So that means as you move along the circumference of the circle here, the direction of aero cap is changing or not? Yes or no? See, at this location it is pointing in this direction, at this location it is pointing in this direction, at this location it is pointing in this direction, and so on. Understood? So that means the direction of aero cap is not fixed. Yes or no? It is varying as you move along what? As you move along the circumference of the circle. Understood? So as you move along the circumference of the circle, what is going to change here? Phi is going to change or not? Yes or no? So that means this direction of aero cap is depending upon what here? Is depending upon phi. Yes or no? Okay. So as phi value changes, the direction of aero cap is changing, and hence aero cap is depending upon what? Is depending upon what? It is depending upon phi. Understood? Okay. So now you may get doubt, sir, whether this aero cap is depending upon rho or not. Is it depending upon rho or not? See, as you move along rho here, let us say you have started from here, you are moving along rho. Understood? You are moving along rho. So whatever the point you can take here, along rho, the direction of aero cap, still it is going to point in the same direction or not? It is going to point in the same direction. That means as you move along rho here, this direction of aero cap is not going to change. So that means aero cap doesn't depend upon rho. Now comes the question, sir, whether this aero cap will depend upon Z or not. Okay, that also we will check here. Now consider this point here, okay, consider this point. Now if I move from this point to this point here, from this point to this point I have moved. So what is going to change? Only Z is going to change. Now at this location, what is the direction of aero cap here? The direction of aero cap is this one. Yes or no? The direction of aero cap is pointing in this direction. Now here this aero cap and this aero cap, both are what? Both are parallel to one another. Or if I move further, that means if I change Z further, okay, so here also at this location also aero cap is going to point in this direction. Now here you consider this aero cap, all the three are what? All are nothing but all are parallel to one another. That means their direction is not changing if you change Z also. Understood? So that means the direction of aero cap is only depending upon what? Is only depending upon phi. It is independent of what? It is independent of rho and Z. Okay, is it clear here? Tell me here. Is it clear? Yes or no? Tell me here. Is it clear up till now? Okay. Okay. So now if you consider A5 cap here, if you consider A5 cap, now let us assume at this point here, what is the direction of A5 cap here? What is the direction of A5 cap? A5 cap is given by the tangent drawn to the circle. Yes or no? Tangent drawn at this point. So if you draw the tangent here, at this location, it is going to point in this direction. Understood? Now at this location, if you try to draw the tangent here, it is going to point in negative x direction, that is into the board. Yes or no? If you draw the tangent at this location, it is going to point into the board, that is A5 cap is going to point into the board here at this location. Now at this location, the direction of A5 cap is given by the tangent drawn at this point. So this is A5 cap. At this location also it is A5 cap. Understood? Now if you draw the tangent at this location, it is going to come out of the board, that is parallel to x axis. Now at this location, it is going to point in this direction. Now if you observe, the direction of A5 cap, is also changing as you move along the circumference of the circle. Understood? That means A5 cap will also depending upon what here? A5 cap is also depending upon phi. So that means aero cap and A5 cap. Both are depending upon what? Both are depending upon phi. Yes or no here? See, if you move along row here, A5 cap direction is not going to change. If you move along Z also, this A5 cap direction is not going to change. See, as you move from this point to this point here, okay, so here also A5 cap is going to point in this direction. Here A5 cap and here A5 cap, both are parallel to one another. Understood? So the direction of A5 cap is not going to change if you change rho and if you change Z. Understood? It is going to change if and only if you change what? Phi. So that means the directions of aero cap and A5 cap are going to depend only upon what? Are going to depend upon only phi. Understood? Now we have to determine how they are depending upon phi, how they are related to phi. That's what we have to determine here. Understood? Now if you consider AZ cap here, understood? So whatever the point you can take on the surface of the cylinder, the direction of AZ cap, will be always what? Will be always parallel to what? Parallel to Z axis. Yes or no here? So whatever the point you can take here, on the surface of the cylinder, understood? Okay, irrespective of the point, always the direction of AZ cap will be always what? Will be always parallel to what? Parallel to Z axis. That means AZ cap direction is fixed. Yes or no? AZ cap direction is fixed. It is always parallel to what? Parallel to Z axis. Understood? Now here only aero cap and A5 cap are depending upon phi. Now we have to determine how these two unit vectors are depending upon phi. Understood? Okay. Anand Seema Kurthi, sir, how to contact you? Okay, here I will give details here later. Okay, so first concentrate on this lecture. Okay. So I hope it is clear here. Up till now. Okay. So now see here. Now we want to determine the dependency of aero cap and A5 cap on phi. How they are depending upon phi. That's what we have to determine. Okay. So I will tell you a simple procedure here. To determine what? To determine this dependency of aero cap and A5 cap on phi. Understood? So whatever we are doing now, okay, so for each and every step here, I am going to give you the reasoning. Understood? Okay, there will be a logic for each and every step. We don't write any step blindly. Understood? Okay, so for each and every step it is going to be crystal clear. Understood? So now see here. Now I will explain how we have to determine the dependency of aero cap along phi. Now see here. Okay. See, you don't get these methods and procedures and in this simple manner lecture, nowhere you are going to get here. You can check anywhere here. That means you can check any textbook or anything. Okay. So you don't get the coordinate system in this simple manner. Understood? Okay. Okay. Yeah. Listen. Aero cap. Now see here. Let us consider a small differential length. I am considering a small differential length. This dl bar in rectangular coordinate system I am writing here. This dl bar is equal to what? Is equal to dx ax cap plus dy ay cap plus dz az cap. Understood? So dl bar I can write it as dx ax cap plus dy ay cap plus dz az cap. Understood? So now this is nothing but LHS side. This is nothing but LHS, that is left hand side. Understood? And this total is nothing but RHS side. This is nothing but RHS side. Understood? Okay. So now here what I am doing here is, now tell me what is the differential length? What is the differential length you are going to get on LHS side? What is the differential length dl bar you are going to get? Okay, so by varying only rho here, by varying only rho, what is the differential length you are going to get? Tell me. If you try to determine the differential length by varying only rho, keeping phi and z constant, you are keeping phi and z constant and you are varying only rho. So then what is the differential length you are going to get by varying only rho here? Tell me, what is the differential length you are going to get by varying only rho? That is nothing but what? That is nothing but d rho aero cap or not? Yes or no? So on LHS side what I have done here? I have determined the differential length by varying only rho. So on RHS side also, I have to perform the same operation or not? That means I have to determine this dx value and dy value and this dz value by varying only what? By varying only rho. Yes or no here? Yes or no? Okay. So you have to determine dx, dy and dz by varying only rho. Because on LHS side we have determined the differential length by varying only rho, that is d rho aero cap, and hence on RHS side also we have to determine the differential length, that is dx, dy and dz by varying only rho. Okay, so how to determine here? How to determine this dx, dy and dz by varying only rho here? See, we know the relation, yes or no? In the previous session I have given here, in the previous class I have given this relation, yes or no? X is equal to what here? X is equal to rho cos phi, yes or no? X is equal to rho cos phi, and y is equal to what? Y is equal to rho sin phi, and z is same as what here? Z is same as z. Right? Okay, we know this relation. So from here you have to determine, you can determine dx value by varying only rho. So in order to get dx by varying only rho, what you have to do? Differentiate on both sides with respect to what? With respect to rho. So if you differentiate on both sides with respect to rho, what you are going to get? Tell me. So that is dx by d rho, that is dx by d rho is equal to what? Is equal to cos phi. Dx by d rho is equal to cos phi. So from here I will get dx is equal to what? I will get dx is equal to d rho into what? D rho into cos phi. D rho into cos phi. Yes or no? So we got dx by varying only rho. So similarly we try to determine dy by varying only rho. Okay, so what you have to do? Differentiate on both sides with respect to rho here. Differentiate on both sides with respect to rho. So what you are going to get? You are going to get here sin phi. So from here, what is dy here? Tell me, what is dy? Dy is nothing but d rho into sin phi. Dy is nothing but d rho into sin phi. Now if you observe here, z here, z is independent of what? Z is independent of rho. Yes or no? And hence what you will get here? If you do dz by d rho here, if you do dz by d rho, what you are going to get? Is equal to 0, because z is independent of rho. Understood? And hence you will get here dz is equal to what? Dz is equal to 0. Dz is equal to 0. So here we have determined dx value, dy value and dz value by varying only rho. Now substitute these values here, substitute these values here. Understood? Okay. So I hope it is clear here. I hope it is crystal clear. Understood? So dx is nothing but d rho cos phi ax cap plus d rho sin phi, this is dy, d rho sin phi ay cap plus dz value is 0 az cap. Understood? Now here d rho, here d rho, here d rho will get what? Will get cancelled. Yes or no? Now we got the expression for a rho cap or not? So a rho cap is equal to what? Is equal to cos phi ax cap plus what? Plus sin phi ay cap. Yes or no here? So we got a rho cap is equal to cos phi ax cap plus sin phi ay cap. Right? So now we can see that this a rho cap is depending upon what? Is depending upon what here? It is depending upon phi or not? Yes or no? The direction of a rho cap is depending upon phi. Understood? So a rho cap is equal to cos phi ax cap plus sin phi ay cap. Now we can check this here. We can check this. Okay. See here. Now if you put phi is equal to 0, okay, so phi, how you are going to measure phi here? Phi is the angle between x-axis and rho. Yes or no? Now let us consider a point here. On the x-axis. Understood? So now if you draw the normal line from the z-axis to this point is nothing but what? Is nothing but rho. So a rho cap is pointing in this direction. Okay, so now in this case the rho and x-axis both are pointing in the same direction, both are present along the same axis. Yes or no? So in this case phi is equal to what? Phi is equal to 0 degrees. Yes or no? So this is x-axis, let us say this is x-axis and this is rho. So whenever rho lies along what? Along x-axis, phi value will be what? Phi value will be equal to 0. So that means a rho cap is going to point along which direction? Ax cap direction. Yes or no? So when phi is equal to 0, a rho cap must point along ax cap direction. So we are getting that or not? See here. So put phi is equal to 0 here, put phi is equal to 0 here, and put phi is equal to 0 here. What you are going to get? If you put phi is equal to 0 degrees, you are getting a rho cap is equal to what? A rho cap is equal to ax cap or not? Yes or no here? Yes or no? Okay. Similarly, if you consider the point here along the y-axis, so the normal distance from here to here is nothing but rho. Now here a rho cap is pointing in which direction here? Y direction. Now here what is the angle? This phi is nothing but what? Phi is equal to 90 degrees. So whenever phi is equal to 90 degrees, that means this is x-axis here, this is rho. Okay, so I am moving this rho further, and now it is pointing along y direction. So whenever it is pointing along y direction, phi value is nothing but what? Phi value is nothing but 90 degrees. Yes or no? When phi equal to 90 degrees, a rho cap is going to point along which direction here? Ay cap direction. Understood? It is going to point along ay cap direction. So here if you substitute phi is equal to 90 here, what you are going to get? Tell me. So if you substitute phi is equal to 90 degrees, what you are going to get? If you put phi equal to 90, this term will go to 0, sin 90 will be 1. So in this case, what you are getting? A rho cap is equal to what? A rho cap is equal to ay cap. So in this manner here, this a rho cap direction is going to depend upon what? Is going to depend upon phi. So as phi varies, the direction of a rho cap is also going to change. So if you substitute different values of phi, you can determine the directions of a rho cap. Understood? Okay. So is it clear here? Tell me here. Is it clear up till now? Okay. Sachin Naik, sir, please explain once how to get vector dl is equal to d rho a rho cap. So have you followed the previous lectures here? You can go through that here once. Okay. You will clearly understand. See, it is simple here. See, we are determining the differential length dl bar by varying only rho. Yes or no? So that means if you move along rho here, if you consider a small differential length along rho, so what you are going to get? D rho a rho cap or not? Yes or no? So the differential length along rho is nothing but what? D rho a rho cap. That's what I have written here. Understood? Okay. So I hope this point is clear here. Sachin Naik, is it clear? Is it clear here? Sachin Naik, is it clear? Okay. Now, now here, similarly, so here what is the procedure we have followed? What is the procedure we have followed? We have determined this differential length by varying only rho, keeping phi and z constant. On RHS side also we have done the same thing. Okay. Now we have to determine. A phi cap, the dependency of A phi cap. Now we have to determine the dependency of A phi cap on phi. Okay. So how we can do that? See here. So same procedure here. What you have to do? So take differential length dl bar is equal to what? Is equal to dx ax cap plus dy ay cap plus dz az cap, dz az cap. Understood? Now what is the differential length? What is the differential length by varying only phi? What is the differential length by varying only phi here? In the previous lecture I have told, yes or no? So if you vary phi, so what is the differential length? You have to consider the differential arc length along phi. Yes or no? Okay. See here. Yeah. See. So this is nothing but rho. So this is also, let us say, rho. So if you move a small differential, length along phi, so it is going to give you what? It is going to give you the small differential arc length. What is the small differential arc length here? Is nothing but rho d phi a phi cap. So this is the small differential arc length you are going to get by varying phi. So that means if you move along phi here, what is the differential length you are going to get? You are going to get differential arc length here. You have to say differential arc length. So what is the differential arc length you are going to get on LHS side? What you are going to get? You are going to get rho d phi a phi cap. You are going to get rho d phi a phi cap. So on LHS side we have determined the small differential arc length by varying what? By varying only phi and keeping rho and z constant. Rho and z are constant. By varying only phi, we have determined the differential length along phi. Understood? Okay. Similarly, we have to determine this dx, dy and dz values by varying what? By varying only phi. Understood? Okay. Okay. So now see here. How we can do that here? Same procedure here. We know that x is equal to what? X is equal to rho cos phi, y is equal to rho sin phi, z is equal to z is equal to z. Now what you have to do? You have to determine dx by varying only phi. You have to determine dy by varying only phi. You have to determine dz by varying only phi. Understood? So do that here. Do that. What you are going to get? So if you differentiate on both sides, you have to differentiate now on both sides with respect to what? With respect to phi. Yes or no? You have to differentiate on both sides with respect to phi, because we want to determine dx by varying only phi. Understood? So what you have to do? So dx by d phi is equal to what? Is equal to, what is the differentiation of cos phi here? That is minus sin phi. So you will get minus rho into sin phi. So from here dx is equal to what here? Tell me. Dx is equal to minus rho d phi sin phi. Understood? Okay. Similarly here, try to determine dy by varying only what? By varying only phi. Yes or no? So what you are going to get here? Dy by d phi is equal to, so if you differentiate this with respect to phi, that is differentiation of sin phi is cos phi. Yes or no? So you will get rho into cos phi. So from here dy is equal to what here? Tell me. Dy is equal to rho d phi cos phi. Understood? Okay. Similarly here z is equal to what? Z is equal to z. Now here z is independent of what here? Z is independent of phi. So if you do dz by d phi, if you differentiate z with respect to phi, what you are going to get? You are going to get 0. Yes or no here? Okay. Okay, so dz by d phi is equal to 0. So now dz is equal to what here? Now dz is equal to 0. dz is equal to 0. Understood? Okay. Okay, Ankit, sir, this is my first class. Okay, yaar, no problem. I suggest all of you to go through my previous lectures also here. Then it is going to be very much effective. Understood? Maybe I am explaining in a very simple manner. So maybe you are able to understand, okay, clearly. But anyway, I suggest to follow the previous lectures also. Okay, then it is going to be super effective. Understood? Okay. So that's why I am saying here. Because most of the students, whenever we say cylindrical, whenever we say coordinate systems, they are having the fear of coordinate systems, yes or no? But I am giving physical interpretation of each and everything, so you don't feel that you are studying some mathematical procedures. Okay, everything you can visualize and you can see and you can digest the concepts easily. So if you understand in this manner, you will never ever going to forget EMTR. Understood? Okay, that's my promise. Okay. Only one thing is, be regular to the class and follow all the lectures, each and every topic in a sequence. Then it is going to be very much effective and it is going to be helpful for you in order to clear many exams here. Understood? Okay. Okay. Now substitute here, coming to the lecture here, see here. Now substitute here in place of dx, substitute what you are going to get, minus rho d phi sin phi, minus rho d phi sin phi ax cap. Now dy is equal to what? Plus rho d phi cos phi ay cap. Yes or no? dz is equal to 0. So dz is equal to 0, 0 az cap. Understood? Okay. So now here on LHS side rho d phi, on RHS side rho d phi will get cancelled. So finally what you are going to get, a phi cap is equal to what? Is equal to minus sin phi ax cap plus cos phi ay cap. Yes or no? Yeah? It is very simple or not? Yes or no? Okay. So what you have to do in order to determine the dependency of a rho cap and a phi cap on phi, how to determine that here? What you have to do? So write down the differential length dl bar in this manner. Understood? On LHS side, try to determine the differential length by varying only rho. If you will get d rho a rho cap, by varying only phi, you are going to get rho d phi a phi cap. Do the same analysis on RHS side also. That is, try to determine dx, dy and dz values by varying only rho. If you want to determine a rho cap, if you want to determine a phi cap, you have to determine dx, dy, dz by varying only phi. Understood? So how we have to do that, I have explained clearly. Understood? Now if you observe here, a phi cap is also depending upon what here? Is also depending upon phi or not? It is also depending upon phi. Understood? So that means if suppose, see, if suppose phi is equal to 0 degrees here, if you substitute phi is equal to 0 degrees. Understood? So if you substitute phi is equal to 0 degrees, a phi is equal to what here? A phi is pointing along ay cap direction. So we will check that here. So this is x axis, this is x axis, this is rho. Understood? So rho is lying along x axis. Understood? Okay. So this means phi is equal to what? The angle between x axis and rho. Yes or no? So phi is equal to 0 degrees. Understood? So now with this, now here I am drawing here. Okay. See here. So this is x, this is y, this is z. So I am considering this circle, okay, of cylinder. I am drawing some rough diagram here, cylinder. See here. This is z. Okay. Okay. So if rho is lying here, okay, rho is lying here at this point I am considering. So this is nothing but rho. So whenever rho is lying here, the angle between x axis and rho, here is phi is equal to 0 degrees. Understood? So here a rho cap is pointing along ax cap direction. We have seen already this. So what is a phi cap here? A phi cap is nothing but tangent drawn at this point. Yes or no? Tangent drawn at this point. So if you draw the tangent here at this point, it is going to point in which direction here? A phi cap is going to point in which direction? A phi cap direction or not? Yes or no? So you are having the circle like this. Yes or no? This is x-axis. So the circle is going like this. Understood? So if you draw the tangent at this location, at this point, okay, it is going to point along which direction? Ay cap direction or not? Yes or no? So that means whenever phi is equal to 0, whenever phi is equal to 0, a phi cap is going to point along which direction? Ay cap direction. Ay cap direction. Understood? Similarly, if you go to this point here, if you go to this point, understood? So at this point is at a normal distance rho. Now here the angle from here to here is 90 degrees. Now in this case phi is equal to 90 degrees. Now if you draw the tangent at this location here, if you draw the tangent at this location, it is going to point into the board or not? It is going to point into the board here. I cannot draw into the board. Okay. So here a phi cap is going to point into the board. So into the board means it is exactly opposite to here. Positive x-axis is coming out of the board. Here a phi cap is going into the board. That means a phi cap is equal to what? A phi cap is going to point along minus ax cap direction whenever phi is equal to 90 degrees, and whenever phi is equal to 0 degrees, a phi cap is pointing along ay cap direction. Understood? Now substitute these 5 values here and check whether we are getting those results or not. Tell me here. Tell me. Okay. Tell me here. So substitute here phi is equal to 0 degrees here. Substitute here phi is equal to 0. What you are going to get? If you put phi is equal to 0, this term will go to 0. If you put phi equal to 0, cos phi will become 1. Yes or no? So you will get a phi cap is equal to ay cap when phi is equal to what? Phi is equal to 0 degrees. We got the same thing here or not? Yes or no? Now put phi is equal to 90 degrees here. So when phi is equal to 90 degrees, when phi is equal to 90 degrees, a phi cap has to point into the board, that is in negative x direction. Understood? Now substitute here phi equal to 90 degrees here in this expression. If you substitute phi equal to 90, this term will go to what? This term will go to 0. Understood? Sin 90 will become 1. So you will get a phi cap is equal to what? Minus sin 90 is 1. So minus ax cap. Minus ax cap. So a phi cap is pointing along which direction? Negative x direction when phi equal to 90. So the same thing we got here or not? Yes or no? So at each and every point here, at each and every point, the direction of a phi cap is given by this expression. This is the expression we have derived. Yes or no? A phi cap is equal to minus sin phi ax cap plus cos phi ay cap. Understood? Okay. Okay. Yeah. Is it clear here up till now? Is it clear? Tell me. Okay, Ankit, my name is Suman. This is my brother phone. Okay, yeah. Okay, whatever it may be. Okay, okay, yeah. Your name is Suman. Okay, fine. Okay, so let me know here. Let me know from your comments. Are you able to understand here? Is it clear? Is it crystal clear? Yes or no? Okay. Is it crystal clear here? Crystal clear. It must be crystal clear. Yes or no? Okay. So we got aero cap. Aero cap as what here? Cos phi ax cap plus sin phi ay cap. Yes or no? Next we got a phi cap. A phi cap is equal to minus sin phi ax cap plus cos phi ay cap. So these are the expressions we got for aero cap and a phi cap. Az cap is same as what here? Az cap is same as az cap only. Understood? It doesn't depend upon rho phi values. Understood? So az cap is always fixed. It is always parallel to z axis. Understood? Okay. Okay, this is what we got here. Now, if you want to check once again whether we have done correct or wrong, what you can do here? We know that aero cap is the radial direction. Yes or no? Aero cap is the radial direction and a phi cap is the tangential direction. Yes or no? We know that radial direction and tangential direction, both are what? Both are perpendicular to one another. So if both are perpendicular to one another, then if you do the dot product here, if you do the dot product, what you have to get? You have to get 0 or not? Yes or no? Since aero cap and A5 cap both are mutually perpendicular to one another. One is radial direction, another one is tangential direction. Always radial direction and tangential direction both are mutually perpendicular to one another, and hence their dot product must become equal to 0. So in this manner we can check whether we have done correctly or not. So if you do the dot product between aero cap and A5 cap, what you are going to get? Whenever you are doing dot product, what I have told here, just multiply the coefficients of x component plus the coefficients of y components. Just multiply the coefficients of x components plus the coefficients of y components. So what you are going to get? Tell me from here, what you are going to get? Tell me. So cos phi into minus sin phi, so that is minus cos phi into sin phi, plus multiply the coefficients of y components. What you are going to get? Sin phi into cos phi. So plus sin phi into what? Into cos phi. So what you are getting here? This is nothing but aero cap dot A5 cap. This is equal to this one. So what we got? So this 2 will get cancelled. So you are getting what? You are getting 0. So that means whatever we have done, that is perfectly correct. Perfectly correct. Understood? Okay. So is it clear here? Yes or no? Okay. Okay. So now, okay. So we have seen how to determine this aero cap and how to determine A5 cap and all. Sir, please send the PDF on Telegram. Okay, okay, I will send here. I will send. Okay, okay. Next here. Now, so we have seen aero cap and A5 cap. Next, see here. Now I am writing the differential lengths here. Differential lengths in cylindrical coordinate system are d rho aero cap, and then rho d5 A5 cap, and then dz az cap. dz az cap. Okay. So next, what is important in cylindrical coordinate system is we have to determine the differential areas. We have to determine the differential areas and differential volume. Okay. So next we will see how to get these differential areas and differential volume. Okay. So in the previous lectures here, whenever we are dealing with a cross product, there I have told that whenever you do the cross product between any two vectors, that is going to give you what? That is going to give you the surface area formed by those two vectors. Yes or no? And the direction of the surface is always given by the unit normal drawn to that surface. Yes or no? Okay. So that's what I have explained in the first lecture. Understood? That means lecture 2 here, in lecture 2 I think. Okay. Lecture 2 coordinate systems, in that I have explained all these things. Okay. So you can go through that. Now here also you can form, here you are having 3 differential lengths here. You are having 3 differential lengths. Understood? So with the help of these 3 differential lengths here, how many differential areas you can form here? How many differential areas you can form? With the help of these 3 differential lengths, how many differential areas you can form? See, if you do the cross product between any 2 differential lengths, you are going to get 1 differential area. So like that, you are having 3 differential lengths. With the help of these 3 differential lengths, you can form 3 differential areas. Yes or no? So if you do the cross product between d rho aero cap and rho d5 A5 cap, you will get 1 differential area. And if you do the cross product between rho d5 A5 cap and dz az cap, you will get another differential area. And if you do cross product between dz az cap and d rho aero cap, you will get another differential area. Understood? Now we will see what are those differential areas here. Okay. Listen here. Okay. Okay here. Okay. See here. So first differential area, let us say dA1 here, dA1. So you can form this differential area by doing the cross product between what? D rho aero cap and rho d phi a phi cap. So if you do the cross product between these two, what you are going to get, tell me? So d rho aero cap cross what? Cross rho d phi a phi cap. Yes or no? See, if you do this, what you are going to get here? Aero cap cross a phi cap. Aero cap cross a phi cap is nothing but what? Aero cap cross a phi cap is nothing but what? Is nothing but AZ cap. Understood? Okay. So here what you are going to get here? If you do the cross product between these two, you are going to get d rho into what? Into rho d phi into aero cap cross a phi cap is nothing but AZ cap. Aero cap cross a phi cap is nothing but AZ cap. So this is the small differential area. This is the small differential area we got by varying what? By varying what are the variables here? Rho and phi. By varying rho and phi, this is the small differential area we got. And what is the direction of this small differential area here? It is along AZ cap direction. It is along AZ cap direction. That means on this small differential area, what are variables? Rho and phi are variables, and Z is what? Z is constant. Yes or no? Rho and phi are variables and Z is constant. So we can call this plane, as what here? We can call this plane as Z is equal to constant plane. We can call this plane as Z is equal to constant plane. And what is the direction of Z equal to constant plane here? The direction of Z equal to constant plane is pointing along which direction? AZ cap or not? Always the direction of any surface is given by the unit normal drawn to that surface. Yes or no? Okay, so for Z equal to constant plane, its direction will be along what? Must be along AZ cap direction. Okay, so now we try to determine the total surface area here. Okay, so first, without doing any mathematical procedures, okay, so first we try to visualize what is the surface area that we can form by varying only rho and phi. Yes or no? Here the variables are rho and phi. So by varying rho and phi and keeping Z constant, what is the surface area that we can get? So that's what we are going to visualize here. Okay, now see here, let us assume this is Z axis here. Here Z axis is present. Understood? Okay, so now vary rho here. Rho is nothing but the normal distance from Z axis. Yes or no? So this is Z axis. Now vary rho and phi. 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 So if you vary rho and phi here, if you vary rho and phi continuously, what is the surface you are going to get? Tell me. What is the surface you are going to get here? Tell me here. What is the surface you are going to get? If you vary rho and phi, what is the surface you are going to get? You are going to get the surface area of a circle or not? Yes or no here? I can give one physical analogy for this one here. See here, you know dosa pan. Yes or no? You know dosa pan. Yes or no? So now take dosa batter here. And put it on dosa pan. Understood? So once you put it on pan, then what you are going to do? You are going to do like this or not? You are going to do like this. Yes or no? So that means whenever you are doing like this, what you are changing? You are changing rho and phi. So finally you are going to get one circular dosa. Yes or no? Okay, so that means if you vary rho and phi, you are going to form what? You are going to form the surface area of what? The surface area of a circle. Understood? Okay? Okay, yeah. So I hope it is clear here. Okay, so now we try to, so we have visualized by varying rho and phi what is the surface area that we are going to get. So now we try to get it mathematically also. Okay, so now if you want the total surface area, what you have to do? You have to integrate on both sides. Okay, so the total surface area A1 is equal to what? Now here the variables are rho and phi. So you have to integrate with respect to rho and you have to integrate with respect to phi. Understood? So d rho into rho d phi. So I am writing that rho d phi like this. Rho d phi AZ cap. Understood? Now if you substitute the range of rho and phi, then you are going to get the surface area formed by what? Formed by varying rho and phi. Understood? Now we know that the range of rho is from 0 to infinity. Okay, that means you can take any value between 0 to infinity. So I am considering rho is equal to some 0 to rho 1, and phi is equal to, what is the full range of phi here? Phi full range is nothing but 0 to 2 pi. Understood? So if you substitute this, what you are going to get? Tell me what you are going to get. So integrate with respect to rho here, integrate with respect to rho, you are going to get rho square by 2, its range is from 0 to rho 1. Now integrate with respect to phi, what you are going to get? Integral d phi is nothing but phi. Okay, so phi, its range is from 0 to 2 pi. Its range is from 0 to 2 pi. So if you substitute the range, what you are going to get? You are going to get rho 1 square by 2 into what? Into 2 pi. Into 2 pi. What is its direction here? AZ cap. Its direction is along AZ cap direction. Understood? So 2 will get cancelled. What you are getting here? Tell me. 2 will get cancelled. You are going to get what? You are going to get pi rho 1 square AZ cap. So mathematically also, what we got? Pi rho 1 square represents what? The radius of the circle or not? Sorry, the surface area of the circle or not? Yes or no? Pi rho 1 square is nothing but what? The surface area of the circle. So that means I am drawing the shape here. So this is nothing but what? So this is the surface area of the circle, and its radius is rho 1. Its radius is rho 1. So the surface area is nothing but pi rho 1 square. Its direction is what here? Its direction is along AZ cap. So that means always the direction of any surface is given by what? Normal drawn to that surface. If you draw the normal to this surface, it is going to point in which direction here? It is going to point in AZ cap direction. Yes or no here? So this is the surface we got by varying rho and phi. Understood? If you draw the normal to this plane, it is going to point in which direction? It is going to point in AZ cap direction. Yes or no? Okay. So this is what we got here by varying rho and phi. Understood? Okay. Is it clear here? Is it clear, guys? Is it clear? Okay. Okay. Next. Okay. So I hope it is clear here. It is very clear. Next. Okay. Or I will go to next page here. Okay, I will go to next page. Okay, so the differential lengths d rho a rho cap, rho d phi a phi cap, dz az cap. Okay, so we have done the cross product between these two. We got one surface. Now we are going to do the cross product between these two differential lengths. So that differential area I am calling it as dA2 bar. So what you are going to get here? Rho d phi a phi cap cross what? Cross dz az cap. So if you do this, what you are going to get? Rho d phi dz into what? Into a phi cap cross az cap. What is a phi cap cross az cap here? A phi cap cross az cap is equal to what? Is equal to a rho cap. So here a phi cap cross az cap, you will get what? You will get a rho cap. Understood? Now on this surface, what are the variables here? How we got this surface? By varying phi. Yes or no? By varying phi and z. Understood? So that means rho is constant. Understood? Okay. So we call this plane as rho is equal to constant plane. We call this plane as what here? Rho is equal to constant plane. Understood? So for rho equal to constant plane, what is its direction here? Its direction is along aero cap direction. Its direction is along aero cap direction. Understood? Okay. So now we try to visualize what you are going to get, what is the surface you are going to get, what is the total surface you are going to get by varying phi and z, Understood? Now here rho is constant here, rho is constant. You have to vary only phi and z. Okay. So now let us consider this is z axis. Okay. Now if you draw a line normal to this z axis, that is nothing but rho. Understood? Now fix this rho here. Rho is fixed. Now you have to vary what? You have to vary phi and z. Okay. So now vary phi here. Vary phi and z. Vary phi and z. Vary phi and z. Understood? So that means you are varying phi and z. Vary phi and z. Vary phi and z. Understood? Okay. So rho is constant here. Rho is constant. You are varying phi z. Varying phi and z. Varying phi and z. Understood? So by varying only phi and z, what is the surface you are going to get here? What is the surface you are going to get? Tell me. What is the surface you are going to get? You are going to get the curved surface of the cylinder or not? Yes or no? Rho is constant. By varying phi and z, varying phi and z, varying phi and z, you are going to get what? You are going to get the curved surface of the cylinder. Yes or no here? Is this point clear? Is this point clear? Tell me. Is this point clear? Yes or no? Okay. So let us see whether we have visualized now. Let us see whether we are going to get the same result mathematically also. Okay. So what is the total surface area? Total surface area is nothing but A2 bar. So in order to get the total surface area, what you have to do? You have to integrate with respect to what? With respect to phi and z. With respect to phi and z. Here rho is constant here. Rho is constant. Yes or no? So integrate with respect to phi and integrate with respect to z. With respect to z. Okay. So the range of phi is from 0 to 2 pi. Z is ranging from minus infinity to plus infinity. So I can take any value between what? Between minus infinity to plus infinity. So I am considering, for simplicity, I am considering z is equal to 0 to z1. Z equal to 0 to z1. Understood? So integrate here rho d phi dz arrow cap. Rho d phi dz arrow cap. Understood? Okay. So what you are going to get here? Here rho is constant. Rho is constant with respect to this integration variables. Rho is constant with respect to this integration variables, and hence you can take it out of the integration. So take rho out of the integration here. You will get rho. Next integrate with respect to phi. So integral d phi is nothing but phi. Substitute its range 0 to 2 pi. Understood? Integral dz is z. So z, its range is from 0 to z1. Okay. So if you do this, what you are going to get here? Tell me. So rho into 2 pi. Here if you substitute, you are going to get 2 pi, and here you are going to get z1. So if you multiply this, you are going to get 2 pi rho into z1. 2 pi rho into z1. And what is its direction here? Its direction is arrow cap. Arrow cap. So what is this surface here? What is this surface area? 2 pi rho into z1. 2 pi rho into z1. Yes or no? So whenever I am starting the cylindrical coordinate system, I have explained how to construct a cylinder. There I have explained this one or not? 2 pi rho into z1 is nothing but what? Is nothing but the curved surface area of the cylinder. Yes or no? 2 pi rho z1 is the curved surface area of the cylinder. And what is the direction of the curved surface area of the cylinder here? Is nothing but arrow cap. Is nothing but arrow cap. So that means if you consider the curved surface of the cylinder here, and if you draw the normal on the curved surface of the cylinder, on the curved surface area of the cylinder, then it always points along which direction here? Arrow cap direction. It always points in arrow cap direction. Yes or no here? The direction of any surface is given by the unit normal drawn to that surface. Yes or no? Now here we got the surface as what? We got the surface as the curved surface of the cylinder. And if you draw the normal, on this curved surface of the cylinder, it always points along which direction here? It always points along arrow cap direction. Arrow cap direction. Understood? Okay. Is it clear here? Is it clear? Let me know here. Is it clear? Yes. Okay, so this is the surface area. This is the surface area we got. This is the surface area we got. Understood? Its direction is along aero cap. Okay, next last one here. Next last one. See here. So, okay, so we have determined the surface area formed by varying rho and phi, and also we have determined the surface area formed by phi and z. Next, what is left out? Varying z and rho. Yes or no? Okay. Next, you have to determine the surface area by varying what? By varying z and rho. By varying z and rho. Z and rho. So what you are going to get here? Simply dA3 bar is equal to what? Is equal to dz az cap cross what? Cross d rho aero cap. D rho aero cap. So if you do the cross product, what you are going to get here? It is simply dz into what? Dz into d rho into az cap cross aero cap. Az cap cross aero cap is nothing but what here? Az cap cross aero cap is nothing but a phi cap. Is nothing but a phi cap. Understood? Okay. So az cap cross aero cap is nothing but what? Is nothing but a phi cap. Okay, is nothing but a phi cap. So this is dA3 bar here. This is another differential area we got. Understood? Okay. See, dz is nothing but the movement along a straight line path. D rho is also the movement along a straight line path. Yes or no? Okay. And we know that this z and rho both are perpendicular to one another. Yes or no? So if you vary z here, if you vary z and if you vary rho, if you vary z, if you vary rho, if you vary z, if you vary rho, what you are going to get? If you go on vary rho and if you go on vary z, what you are going to get? If you multiply these two, you are going to get what? You are going to get the surface area of a rectangle. The surface area of a rectangle. Yes or no? Okay. So you can easily visualize that here. You can easily visualize that. So if you want to determine the total surface area, what you have to do? You have to integrate with respect to z and you have to integrate with respect to rho. So dz, d rho, a phi cap. So let us take z is equal to 0 to z1, rho is equal to 0 to rho 1. So you are going to get rho 1 into z1 here. I am writing directly here. It is very simple. Yes or no? Integral dz is z. If you substitute the range, you are going to get z1. Integral d rho is rho. If you substitute the range, you are going to get rho 1. Understood? So its direction is what here? Its direction is a phi cap. So this rho 1 into z1 is nothing but what? It is simply like length into breadth. Yes or no? So it represents the surface area of what? The surface area of a rectangle. So the shape you are going to get is nothing but the surface area of a rectangle. The surface area of a rectangle. Understood? Okay. So what are the surfaces we got here? What are the surfaces we got? So by varying rho and phi. So in cylindrical coordinate system, what are the surfaces we got here? What are the surfaces we got? So by varying rho and phi, we got the surface of a circle. Understood? And if you draw the normal to the surface of a circle, it is going to point along az cap direction. So this is one surface. Understood? Next, keeping rho constant, if you vary phi and z, keeping rho constant. So rho is constant. If you vary phi and z, you are going to get what? You are going to get the curved surface of the cylinder. And what is the direction of the curved surface of the cylinder here? It is given by the unit normal drawn to that surface. Yes or no? So if you draw the unit normal on the curved surface of the cylinder, it is going to point along which direction? Aero cap direction. Understood? So this is the second surface we got. And third one is very simple one, that is if you vary z and rho by keeping phi constant. Yes or no? We got simply a rectangular surface. So that means we can call this surface as what here? We can call this surface as phi is equal to constant plane or not? Yes or no? Phi is constant on this plane. Rho and z are variables. Phi is constant on this plane, and always the direction of phi is equal to constant plane is going to point along which direction? Is going to point along a phi cap direction. So these are the three planes we got in cylindrical coordinate system. Okay, these are the three surfaces you can form in cylindrical coordinate system. Okay, is it clear here? Is it clear up till now? Tell me here, respond here. Yes, yes, very good here, very good. All the three are circle, cylinder and rectangle. Very good. Okay. Okay. Now, now, what is the volume here? What is the volume? What is the volume? How you can get the volume here? Tell me. How you can get the volume? What is the concept I have told? Okay, so take any surface and extend that surface in its perpendicular direction. You are going to get the volume. That's what I have explained or not? Yes or no? While explaining rectangular coordinate systems, what we have done? So we have taken, let us say this is x-axis and y-axis. So if you consider a small differential area in xy plane, so let us say this is dx, dy. So if you extend this surface along z direction by dz units, you are going to get what? You are going to get the volume. Okay, so that means whatever the surface, you can take surface and extend that surface in its perpendicular direction. You are going to get what? You are going to get the volume. Understood? Now here in cylindrical coordinate system, what are the surfaces we got here? We got one circular surface, yes or no? So this is nothing but z is equal to constant plane. What are variables? Rho and phi are variables. Yes or no? And its direction is along az cap direction. So what I said here? Take this surface here, and extend this surface along az cap direction. What you are going to get? It is just like what? Take the circular disc. So place such type of circular discs one upon the other up to some height h along az cap direction. Understood? You are going to get what? You are going to get the volume of the cylinder or not? Yes or no? So that's what I have said. So take this surface and extend this surface along its perpendicular direction. You are going to get what? You are going to get the volume of the cylinder or not? Yes or no here? So this is one case. Next, another one. Now what we have done here? Phi and z are variables. So with this, what we got? We got the curved surface of the cylinder. Understood? So we got the curved surface area of the cylinder like this. If phi and z are variables. So we call this curved surface area as rho is equal to what? Rho is equal to constant plane. So wherever you will move on the curved surface of the cylinder, rho value is going to be constant or not? Yes or no? The radius of the cylinder is going to be constant. Understood? Okay. So what I have said here, take this surface here, and what is its direction? If phi and z are variables, then rho is constant. The direction of the curved surface is nothing but what? Is along arrow cap direction. So if I draw z axis like this, okay, let us say this is z axis. Understood? Okay. So now here the direction, this is nothing but arrow cap. So the radial direction, this is nothing but arrow cap. Radial direction. Yes or no? Okay. So now what I said, take this curved surface and you have to extend this curved surface. Along which direction? Along arrow cap direction. Then what you are going to get? Now let us take, I will explain this here. Let us take a small curved surface here. A small curved surface of the cylinder. Rho is very small here. Okay. A small curved surface of the cylinder. Understood? Now what you have to do? You have to extend this curved surface. In its arrow cap direction. So that means I can assume that in this manner or not. So if you extend arrow cap, you are going to get somewhat bigger cylinder like this. If you extend further arrow cap, you are going to get somewhat bigger cylinder like this. If you extend further arrow cap, you are going to get further bigger cylinder like this. Understood? So now if you join all these concentric cylinders, you are going to get what? You are going to get the volume of the cylinder or not? Yes or no here? So take this curved surface of the cylinder, and if you extend that curved surface of the cylinder along which direction? Along its perpendicular direction, that is along aero cap direction. That I can assume as, if you place the concentric cylinders one after the other continuously, okay, up to some rho value, you are going to get what? You are going to get the volume of the cylinder or not? Yes or no here? You are going to get the volume of the cylinder. Is it clear here? Is this point clear? Yes or no? Sachin Naik, Ankit, and whoever watching, respond here. Is it clear? Okay, so take this curved surface and extend that surface along its perpendicular direction. You are going to get the volume. You are going to get the volume. Understood? Okay. Next. Next, what are variables here? Rho and Z. Rho and Z are variables. Rho and Z are variables. So with rho and Z variables, we got what? We got the surface of a rectangle. So I am drawing the surface of a rectangle here. See here how I am going to draw that. See here. So this is the cylinder. This is the cylinder. Okay. So this is Z axis, and this is X axis. This is Y axis, this is Z axis. Okay. So I am showing how you are going to get the surface of a rectangle in cylindrical coordinate system. That's what I am trying to show. Okay. Now here, see here. So now here, from here, the normal distance from here to here is nothing but rho. Understood? Okay. So if you vary rho and vary Z, vary rho and vary Z. Understood? Okay. So I have varied rho and now I am varying Z. I am varying Z. Understood? So this point is also at the same normal distance rho. Same normal distance rho. So now this is rho and this is nothing but Z. This is nothing but Z. So rho into Z will give you what? Will give you this surface area or not? Is going to give you this surface area. So this is the surface area of what? Surface area of a rectangle. Surface area of a rectangle. So that's what we got here. Here what is constant here? Here what is constant? This is nothing but phi is equal to constant plane. So this rectangle is nothing but phi is equal to constant plane. So that means the direction of this rectangle is going to point in which direction? It is going to point in a phi cap direction. It is going to point in a phi cap direction. Understood? Now see why we are calling it as phi equal to constant plane here. See the angle here is nothing but what? The angle here is nothing but phi. If you consider somewhere here, okay, if you draw the line that is parallel to x axis, this angle is also nothing but what? This angle is also nothing but phi. If you consider a line that is parallel to x axis, the angle from here to here is also nothing but what? Phi. So throughout this plane here, the angle made with respect to x axis is nothing but what? Phi or not? Yes or no? So phi is constant. Phi is constant over this plane. Over this plane, phi value is going to be constant. So that's why we call it as what? We call it as phi is equal to constant plane. We call it as phi is equal to constant plane. Understood? Now what we have to do? If we extend this surface, along its perpendicular direction, we are going to get what? We are going to get the volume of the cylinder. Yes or no? See, now take this surface of the rectangle here. Now if you try to rotate, this rectangular surface, in anti-clockwise direction. Why we are rotating in anti-clockwise direction here? Because you have to extend this surface along which direction? A phi cap direction. A phi cap direction means what? You have to rotate. In anti-clockwise direction. Understood? So take a rectangular surface like this. So if you rotate this rectangular surface in anti-clockwise direction, that is going to form what? That is going to form the volume of the cylinder or not? Yes or no here? So here also you are going to get the volume of the cylinder. So these are the three planes we got here. That is Z is equal to constant plane, its direction is along AZ cap. Rho equal to constant plane, its direction is along aero cap. Yes or no? Phi equal to constant plane, its direction is along a phi cap. Now, if you extend any of these surfaces, in their perpendicular direction, you are going to get the volume of the cylinder. Yes or no here? Okay. So, is it clear here? Is it clear? Everybody, is it clear? Yes or no? Tell me here. Yes or no here? Okay. Okay. So finally, we try to get the mathematical expression for volume of the cylinder. Okay. So here the differential lengths d rho, a rho cap, rho, d phi, a phi cap, dz, az cap. Understood? So what is the differential volume here? Tell me. So in order to get the differential volume, what you have to do? So take any surface and extend that surface in its perpendicular direction. So you can form the surface by doing the cross product between these two differential lengths. So you can do like this. So d rho, a rho cap, cross what? Cross rho, d phi, a phi cap. So this is the surface. You have to extend this surface along z direction by dz units. Okay, so I have told in the first class itself, okay, we have to do here cross product or dot product. What you have to do? You have to do dot product. So why and all I have explained in the previous lecture itself. Understood? While dealing with rectangular coordinate system. Yes or no? So what you are going to get here? You are going to get d rho into rho d phi, a rho cap cross a phi cap is az cap, a rho cap cross a phi cap is az cap. So az cap dot az cap will become 1. So you will get simply dz. Okay. So the differential volume is nothing but the resultant of what? The resultant of the dot product or not. So here we got one vector. Understood? Here there is another vector. So if you do the dot product between these two vectors, finally you are going to get the scalar quantity, and hence the volume is what? Volume is a scalar quantity. Understood? So go through my previous lectures here, you will understand each and everything clearly. Okay. Okay. Now if you want the volume here, total volume, what you have to do? Now here the variables are rho, phi and z. So you have to integrate with respect to rho and phi and z. Yes or no? Let us consider the range of rho is from 0 to rho 1 and the range of phi is 0 to 2 pi. I am considering the total range of phi. So z is equal to 0 to z1. So if you do this, what you are going to get here? Rho d phi dz. So if you integrate with respect to rho, phi and z, what you are going to get? What is the volume of the cylinder? Is nothing but what? Pi rho square z or not? Yes or no? Okay. So we will check whether we are getting that result or not. So integral rho d rho, that is rho square by 2, its range is from 0 to rho 1. Integral d phi is phi, its range is from 0 to 2 pi. Integral dz is z, its range is from 0 to z1. Yes or no? Okay. So now what you are going to get? Tell me. You are going to get rho 1 square by 2 here, multiplied by what? Multiplied by 2 pi, multiplied by what? Multiplied by z1. So here 2 will get cancelled. So what we are getting? What you are getting here mathematically? The volume of the cylinder is nothing but what? Pi rho 1 square z, and volume of the cylinder is nothing but what? Is nothing but a scalar quantity or not? Yes or no? Okay. So this is the volume of the cylinder. So mathematically also we have got, and also I have explained how we can get the volume of the cylinder with the help of what? With the help of the three surfaces that we got in cylindrical coordinate system. Understood? Okay. Okay. So I hope it is clear here. I hope it is clear each and every point in today's lecture. So we have seen how to determine a rho cap and a phi cap, and also we have seen how to determine the differential areas and differential volume, and also we have seen how we can get the volume by extending the surfaces along their perpendicular direction. Understood? So all those things we have seen here in today's lecture. Okay. So I hope it is very clear here. I hope it is clear. Okay. So give some comments here. Is it clear today's lecture? Is it clear? Respond here. Give some comments here. Respond. Okay, yeah. So I hope it is crystal clear here. Okay, so with this I am winding up this session here for today. Understood? Okay, so daily at the same time 4 p.m. We are going to have this EMT lectures here. Okay, for the next 25 days you are going to get daily at 4 p.m. you are going to have this EMT lectures. Understood? So please utilize this opportunity effectively. Okay, and gain some knowledge here, and also get rid of the fear of EMT here. Understood? Okay, so it is very simple, interesting and beautiful subject if you are able to understand the concept clearly, and if you are able to visualize the things clearly, then it is the most beautiful subject in engineering stream. Okay, that means in ECE and electrical stream, this is the most beautiful subject. Understood? Okay, yeah. Okay, thank you here. So today I am winding up the session. So tomorrow we are going to meet at the same time here. Okay, so take care. Bye bye.